Hi, everybody, and welcome to this AWS session on high-performance computing. My name is Praneeth Reddy, and I'm the CTO of Jasper Solutions. We're an innovator in the federal government space, supporting military and civilian federal customers, state and local governments, and commercial customers in the infrastructure, software development, DevSecOps, AI, and high-performance computing spaces. I'm excited to be with you today to talk about how Jasper and AWS work together to implement a first-of-its-kind managed services offering in the high-performance computing field for the federal government. Our customer is the Department of Defense, US Army, ERDC. It says ERDC is a research organization of the US Army Corps of Engineers. ERDC's 7 research laboratories are located in Illinois, Mississippi, New Hampshire, and Virginia, and they function as an integrated team of engineers and scientists to address a broad range of science and technology issues, from operating in Arctic temperatures to vehicle mobility in desert sands, to protecting wetlands, to protecting US troops around the globe, to pinpointing the exact location of an artillery round, to predicting the extended habitat range of an endangered species. Their work includes areas like geospatial research and engineering, military engineering, cold region science of engineering. They do have a base in Antarctica. Environmental quality and installations, water resources management, and engineered resilience systems. Now, to give you an idea about how they operated before we started this high-performance computing use case, ERDC infrastructure consisted of specialized supercomputing infrastructure, which had 2 variants. The first variant was a Cray XC4050 Lustre, which was able to perform 6.06 petaflops of compute with 176 large memory nodes of 4 cores, 2,048 regular nodes with 32 cores, 704 GPU-accelerated nodes of 32 cores each, installed on Cray Linux. This is just to give you an idea of the computing infrastructure, combined with 13 petabytes of storage. They also had another variant, which was a Supermicro super server with about 26 2-GPU nodes, 8 4-GPU nodes, and 5 8-GPU nodes with Intel Skylake processors using the Red Hat Linux operating system with a combined storage of 3 petabytes. The way the system operated was that different groups around the world and partners who were working with ERDC would make reservations through this arcane procedures that were developed when it was first established in 1998 and were refined over this time period. They involved heavy communication and scheduling and competition for reservation slots. There was a jungle out there. Queuing and scheduling were managed at the system level, and the result of this was the natural overutilization and underutilization that comes with a fixed computing infrastructure. Some of the biggest pain points were there were times of oversubscription and there were times of underutilization, especially because ERDC was working with universities all around the world, research labs all around the world, and government agencies. Each of these different groups had different cycles of requirements. For example, most of the student activity revolved around the academic calendar, whereas research grants revolved around the grant calendar, and government agencies revolved around the financial calendar. So this led, it was very hard to optimize and keep all of these groups happy and productive and not waiting at the same time. There were times when groups were waiting for upwards of 2 months to run a 2-day job. This was clearly something that ERDC, our customer, wanted to address. Other pain points included hardware procurement cycles being really long. There were bids to be made, bids to be processed by the government, bids to be awarded and procured and audited in order to meet all the government regulations around this entire process. Any kind of supplier disruptions because of really specialized hardware also led to long wait times for people with specialized computing requirements. The upgrade cycle was a lot longer because installation verification took a really long time. And they also had pain points like they were using Cray Linux, which is a very specialized version of Linux. So the availability of libraries, compilers, jobs, and the general documentation around running specialized computing on a specialized operating system was not as big as it was for other development environments, other set of libraries, and other ecosystems. So the supporting ecosystem was never in sync with the needs of the user base. It really struggled to keep pace. So ERDC decided to start utilizing cloud and start moving their compute to the cloud. They wanted a hybrid high performance computing system where they could choose, where they were flexible in choosing between on-prem and cloud resources. They wanted a seamless user experience for workload submission and a process where submissions were approved very quickly and cleared very quickly, and people were authorized to run their jobs. We are talking about scientists here. They love working on their technology and science, and they're really turned off by having to put on a bureaucratic hat and go looking for sponsors and resources and the attendant bottlenecks that come along with that. And since a lot of this user base was very transient, people would join high performance computing groups and leave very frequently. And since some projects were long term, some projects were short term, so the entire user base was in a lot of flux. Onboarding was also an issue. They needed a secure environment with federal compliance standards. And since ERDC was partnering with even foreign research organizations and the private sector, the security field was really complicated to address all the security requirements that they were required by law to follow, especially when it came to following DOD requirements. So they needed an infrastructure that would come inbuilt with federal compliance standards already satisfied, so they could build on top of that. In some cases, some of the jobs required virtually unlimited resources, unlimited scale, and latest hardware and software. In addition, all of these jobs also required that the budget, the cost of executing that job, be allocated in a fair manner, which is really hard to do with a shared computing infrastructure. So what prevented ERDC from moving to the cloud? Until GovCloud, there was no precedence for moving a workload from on-premise infrastructure to the cloud. In addition, facilities security has always traditionally been managed by the government. So there were members of the Army, Navy, and Air Force who were guarding the installations in which the computing resources were located. And in order for anybody to get access to this, they had to pass through security that was managed by the government. And this has long been the tradition in the Department of Defense. So it also required a shift in mindset in trusting a facility that is not directly under their control. And when it comes to security, some of these mindset shifts take a long time. The government has very strict restriction on how money is allocated and utilized. And there is an ocean of rules that percolate from various laws, which are state, local, federal, and the resultant conflict that arises from those laws. So the move to a cloud always required a standardized process through which this all could be facilitated. In addition, reporting requirements were very detailed, and the decision to move on from a system that works is something that is very, very hard to make for people in charge. So until GovCloud, this shift from these many different factors was really hard to conceive of for the leadership higher up in the organization. But once AWS GovCloud was certified to operate IL2, Impact Level 2, Impact Level 4, and Impact Level 5 workloads, which I'll explain in my next slide, it became feasible for high-performance computing to take advantage of this move to the cloud. So why did ERDC choose HPC on AWS? AWS had really good infrastructure and documentation for parallel cluster management, more so than any of the other cloud providers that are out there. The AWS team worked really closely to accommodate the reservation of computing power, especially when it comes to reserving compute power for high-performance computing workloads. The scale of resources that need to be reserved is a lot higher than any other use case. This involves really close coordination between the managed services team of Jasper and the managed services team of AWS, and they did a wonderful job of facilitating both the evaluation as well as the production operation of workloads. We have settled into a really smooth and seamless pattern of coordination almost weekly in order to facilitate how these jobs are run and to make sure that the compute power is directed to the right instance, and which leads to a much higher success rate of executing this high performance computing workloads. In addition, the concept of releasing a resource after use and not paying for it is very attractive to the government from a budgetary standpoint. Infrastructure as code is a very powerful concept when it comes to reusing the work that one group does in order to facilitate and speed up the work of another group. I will describe how our customers experienced each of these advantages in the subsequent slides. So AWS GovCloud provided the following 5 main advantages. AWS GovCloud is designed to support customers with US government compliance requirements. It restricts all physical and logical access to GovCloud and all potential access to restricted customer data to vetted US citizens on US soil. They have a very, very good infrastructure and certification procedures in place and compliance procedures in place in order to facilitate this and to pass on these advantages to managed services providers like Jasper Solutions. GovCloud is the same security level as a commercial cloud, but it differs in compliance, especially for commercial organizations that use it. So some of the features, for example, are that the root account holder must be a US citizen, the commercial customer organization must be a US corporation incorporated in the US, and the commercial customer organization is not barred from handling export control data. And AWS enforces all of these requirements from their GovCloud. Further, identity and access management provides audit logs where we can ensure that the right people get access to the right resources and that all access to resources is monitored and logged for any future investigations. AWS GovCloud has really granular budgeting APIs, which allow us to accurately allocate compute usage costs to the customers who are responsible for generating those costs. The cluster management was excellent. The APIs provided were really good, and the support provided was of the highest class. In addition, the AMIs that were available to us for high performance computing infrastructure were really high in quality and easy to use, which allowed our developers in the high performance computing environments to get started with their execution of their tasks really quickly. In terms of security requirements, Impact Level 2 Assurance is a certification that verifies the security level of a network. All government departments, including local governments, are now covered by such security standards. This includes schools, health departments, defense, local governments, state governments, and autonomous organizations. The risk management framework is the common information security framework for the federal government and its contractors. The stated goals of risk management framework are to improve information security, to strengthen risk management processes, to encourage reciprocity among federal agencies, and it standardizes and recommends a 6-step lifecycle process consisting of preparation, categorization of information systems, selection of security controls, implementation of security controls, assessment of security controls, authorization of information systems, and monitoring of security controls. The standards for these are governed by, in partnership with National Institute of Standards and Technology, NIST for short, in partnership with the Joint Task Force Transformation Initiative. These two organizations have developed a series of publications that provide detailed guidance on RMF implementation, categorization, and security controls. Jasper Solutions specializes in implementing risk management compliance with the guidelines specified by these standards bodies, and we have been in this business for the last 18 years. And in this high-performance computing project, it was really a breeze to implement RMF compliant standards and documents in almost an automated fashion. Identity and access management was very critical to this whole high-performance computing workloads because we had to identify who was logging into the system, who was running a job, how long they were running it, who generated what amount of cloud bills, and who were accessing the various resources that were enabled inside the IAM framework with AWS. We also implemented multi-factor authentication. It took us less than a week to implement and onboard all the customers. And this was during the peak of the coronavirus pandemic when a lot of places were shut down. We still managed to receive our tokens in a timely manner. So thanks to AWS for coming through when our customer was really demanding that we implement this at a really short notice. We were able to come through for them. And in addition, we used CloudWatch for accounting through logs in order to ensure that resources that were provisioned were being used and were not idle. One of the biggest requirements from our customers was obviously the cost of every job, the cost of computing resources used by a group in a time frame that the customer wanted. The customer wanted really granular information, all the way down to CPU utilization, network utilization, and disk utilization. And Jasper Solutions use the AWS CLI and AWS Lambda to build really sophisticated dashboards that served our customers. And we hooked it up to widely available business intelligence tools to create a dashboard that allows our customer to make both tactical and strategic decisions. We used CloudWatch and we combined it with other open source monitoring tools in order to detect idle clusters, in order to detect when a user or a group had overshot their quota. One of the places where we could improve is the granularity of billing. I'm not sure if it's a problem that can be solved to reduce the granularity to less than 1 day, but we were able to achieve a billing granularity of 1 day in order to enforce quotas and budgets. Cluster management was really easy to level up our engineers. The documentation available was really helpful and to the point, and we were able to master the usage of clusters within a week, and we were able to transfer this knowledge to our customer in less than a week. We are using tagging to enforce quotas, and we are using IAM restrictions around tagging to ensure that everybody tags their resources appropriately to run their high-performance computing workloads. We use these tags and the CloudWatch metrics in order to assess the usage and budgets of every single user and every single group to generate some very sophisticated reports centered around capacity. We, at the macro level, we worked very closely with the AWS team to do capacity reservation. We had weekly calls where we would project the workloads out uh, for the next 2 to 3 months, and we would adjust these projections on a weekly call. And we were able to provide all the infrastructure that was required by our customer without a single day where somebody was waiting for compute resources that were not available. So just to give you an idea, we had a group that was waiting for 2 months to run a 2-day job, and we were able to give them access to enough computing resources to run a 7-day job within 7 days. So this was a huge improvement, and our customer was very happy that we were able to come through uh, with the resources required. We also implemented some sophisticated algorithms for idle compute resource detection, because when a lot of clusters are running, the cloud bills start adding up. So, and people blow by their quotas really quick. And we have to, since the granularity of billing is 1 day, a lot of the times quotas get enforced 24 hours later. So we are using some very sophisticated algorithms for projecting the usage for the jobs that people are planning. We are still in the process of implementing and refining this, but we have high confidence in some of the algorithms that we have developed to improve the accuracy of these projections and to retroactively adjust our algorithm to account for any overages. One of the biggest advantages that our client was able to get from us was composable infrastructure. We used AMIs, and we built and managed AMIs on the fly to give our HPC users access to a vast library of cataloged, tagged, and versioned AMIs where they could search, pick the right AMI, and execute a job uh, at a very short notice. So they spend most of their time working on their code instead of trying to solve operating system issues or trying to solve library compliance issues or trying to find the right compiler which allows them to execute a particular HPC workload on a particular set of processors or GPUs or operating system or looking for dependent libraries and so on. We've also implemented um, configuration management in order to standardize these AMIs so other groups can also use it. They can search our library and find the appropriate AMIs that they need to use it. Users can tag it and share it with each other, and so on. We've also provided personalized recommendations to the user, to the computing user, about which AMIs would best suit their applications. We have encouraged our users to contribute to our shared knowledge base. So people who execute jobs and have lessons learned associated with executing that job can be shared widely across the organization. So I would also like to describe the journey that we've been through over the past 1 year with our customer and with AWS. It all started with getting our first pilot user on board. We had to do a lot of work getting the high performance computing infrastructure certified to pass the risk management framework controls that were defined over and above the controls that are already present in Impact Level 2 on AWS GovCloud. We were able to accomplish that in early April. By May, we had onboarded our first user. The first user was evaluating the managed services that we were providing He was evaluating the APIs that were available for him to run clusters, and he ran a variety of jobs in a shared. We would spend hours on a conference call watching all of these jobs being executed and refining our process for supporting and providing HPC managed services to ERDC. Once the pilot user was able to run his benchmarking tests against his set of diversified jobs, this was then escalated to a pilot group, which was then brought on board to run a much more rigorous series of tests to test workloads of different scales. This was called the benchmarking group, and the benchmarking group in ERDC was responsible for benchmarking high, medium, and low workloads of various compute capacities. They tested the GPU workflows, they tested cluster workloads, they tested AI and ML, and they provided a detailed feedback back to our customer, who's the director of ERDC. And they were uniformly thrilled with the speed at which these jobs were executed. Jobs were anywhere from 2 to 20 times faster than they had experienced with their previous, with their on-premise infrastructure. And they were really amazed at the wealth of compute capacity that was available to them, both from a volume front as well as from a quality front. And we finally turned the service on for production users. The benchmarking and everything else took place in a development environment. And once the customer was satisfied that we had passed all the quality checks and we would be able to support them in this managed services offering, we got the green signal to launch the service, and it has been operating since July. Our customers have nothing but good things to say about us, and they're really excited to where we can take this effort next. Just to give you an idea to you, end user, about our journey in the last 1 year, it has been amazing to work with a brilliant group of engineers from AWS and some of the finest scientific minds in the world. It has been a very revealing experience. I myself am from an engineering background, and I fell in love with computers at a very young age. And to follow this journey and to see computing in its purest form gives me great joy. And thank you, AWS, and thanks to our customer for giving us this opportunity to demonstrate our high-performance computing managed services capability. Thank you.